My name is Keith, this is Lior, and we're going to be talking to you today about moving towards a standardized identity-based authorization policy within Kubernetes. It's a big mouthful, but hopefully by the time we're done, you should understand what all those things mean, maybe even have an opinion about it. So let's start from the very beginning. I hear that's a great place to start. So when you talk about policy, you're probably wondering, why should I care? Some of you may be wondering, why should I care? And the way I like to think about this is that we're very used to thinking about policy happening at the edge of our system. Think about things like DDoS attacks, or AI scrapers, or persistent threat actors. Those are typically scenarios where somebody on the outside is doing their best to get into the inside of your system. Yes, yeah. OK, wonderful. So as I was saying, typically we think about policy at the edge of our system. And every organization is going to deploy a myriad of software and fancy acronyms in order to try to deal with those threats. Who in here has heard of a web application firewall, or a WAF? Raise your hand. Right. What about, keep it raised if you've heard of SSO, single sign-on. You can put your hands down now. Like bot detection or JOT verification, these are all fairly common practices that you see in just about any system that lives on the internet. And all of these have some form of policy that keep your cluster, keep your system safe from outside threats. And so as we sort of move to this conversation of identity-based policy, it helps to generalize and understand what all these solutions have in common. And this is where we get to our definition of policy in one simple sentence. At a high level, access policies define what actions a given entity can perform under specific conditions. And for the rest of my time I'm talking right now, we're going to be talking about the entity part specifically and breaking down the different scenarios that you can run into. And so in any system, again, going back to our general look at software and computing, you can do authorization and access policy both at the boundaries of your system as well as within the boundaries of your system. And it's not super intuitive, but actually some of the most harmful exploits, the most impactful security vulnerabilities actually happen within your system. And so it's interesting how we spend a lot of time talking about SSO, web application firewalls, all those sorts of things happening at the edge of our system. It's also important to look at what's happening within our system. Think about if you have a disgruntled employee who tries to spend their time ruining the company. Or you have an ex-contractor who leverages access that should have been revoked. Confused deputy attacks, stateful sessions with delayed revocation. All these scenarios are all situations that can really harm an organization, and they originate from within a trusted entity inside of your system. These sort of scenarios are exactly why things like defense in depth and zero trust philosophies sprouted up. They're meant to prevent these sorts of vulnerabilities from escalating. The idea behind this is that you don't assume, rather that you do assume that all the previous layers of your security fail. So you create your security posture as a series of layers as opposed to just one specific enforcement mechanism. You also try to reduce any sort of have no universally trusted machine or no super user or God mode, those sorts of things. Only give each entity their access and permission that they need. If your policy is restricted to just the boundaries of your system, you're really leaving yourself open to very critical exploits. And so if you're from a network background, these terms might make sense. But in case you're not, when we talk about traffic flowing within the system, we call that east-west traffic. It moves from service to service, one side to the other. Whereas when you have traffic that's entering or leaving your system, we call that north to south. And so similarly, authorization policy that happens within your system, we're going to call that east-west authorization. When you break this down, and again, this is the policy happening within your system, there's actually a lot of common characteristics that we can take when we're thinking about these scenarios. For one, the entity in question is usually a machine instead of a human being. Access is per transaction, and you typically are going to need multiple things enforcing your policy as opposed to just a single layer, a single instance of policy happening at the edges of your system. Kubernetes is a very powerful, very common system, and so it falls in this category as well. And so because Kubernetes is a declarative system, users come to Kubernetes wanting to make declarative statements about the access control in their system. You've probably heard of users saying something like, my service foo should only be able to talk to service bar, but I only want that to happen on port 80, or something like that. And the most security conscious users want this to be additive in nature. And so we often see that happen in a default deny posture. And then you add one by one the layers of the things that are allowed to talk to one another. Now, Lior is going to talk to us about more what Kubernetes has to offer specifically in this area.
Right. So, what Kubernetes offers us today. Let's do a quick rundown for things that probably most of us are already familiar with. Starting with network policy v1, right? This is how we do it within Kubernetes. This API lets app owners control traffic from and to their cluster. We can see the egress and egress there. The sources and destination entities are usually in form of IPs or some abstractions on top of IPs, whether it's IP blocks, whether it's label selector, all are just abstractions, as I said. It's a namespace scope policy. Means usually we expect the app developer to control there. And it's installed by Kubernetes by default. It requires network plugin implementation, which we often call CNI. And it's stable for, I think, almost 7 years, or a little bit more than over 7 years now. And this comes with a few gaps, right? Like there is an implicit deny first. You just define what you can allow, and you have no option to define deny policies. It means that everything you're not allowed is implicitly denied, and this has been a source of confusion for many users right now. There's no support for cluster admins, so policies are namespace scope. There's no way to define strong and higher priority policies. Policies entities are on the IP level, not identity, and within Kubernetes, IPs are ephemeral. Workload owners as well do not usually interact with APs. They just get it. It's get assigned to their workloads. And security policies should ideally be tied to identities and not to IPs. And we're going to talk a little bit more about it later. And lastly, there's some issues with scalability when we talk about especially label selectors as a source, when we talk about tying and caching all these APs. And there is issues with eventual consistency and especially where this eventual consistency can lead to permissiveness. Now, some of the smart folks here came up with admin network policy, baseline network policy, which is solving some of these problems by introducing cluster scope policies. And these cluster scope policies can let you enforce mandatory and non-overallowable policies for your tenants or users. And similarly, you can enforce tenant isolation, or you can even delegate traffic to your app developers to do with network policies. There is added support for deny rules and priorities, which is increasingly useful. And one thing to note, the sources and destination entities has the same semantics as network policies. They are still abstractions on top of IPs. And then two more facts. It's out of tree API for those who are not familiar with it. So it's a CRD, requires a CRD installation. And it also is implemented by the network plugin implementation. Now, this is just how it looks like as a one quick overview, like the order of evaluation. We have admin network policy. If there is no match, or there is a pass rule, which means delegate to network policy, that's where network policy comes to the picture. That's the app developer define what they need. And if there is no matching network policy, that's where baseline network policy, the ability to define cluster default to align with the zero trust model with all the security postures, the community is trying to achieve. That's where you define that. Now, we solved the two first problems, right? Like we have an ability to define deny policies. We have the ability to support cluster admin operations, but the policy entities are still on the IP level and not identities. And the scalability and eventual consistency is still there because of that. And there is also slightly increased complexity, right? Because we have priorities, and the discoverability is challenging. Now, there is a lot of good tooling, which the SIG-Network API community have worked for, but same with every network policy attachment. It's pretty hard to kind of define and understand what policy is effective for my workload at any given point. Now, just to recap and kind of lead me to the next bullet. So the Kubernetes network policy entities are usually, again, label selectors, namespaces, nodes, CIDRs, and all our forms of IP abstractions. And what are the challenges with this model? What are the challenges with us translating things to IPs and relying on that? So as we said, scalability, right? Label selectors produce subset of pods. And the ingress and ingress rules define access control between those subsets. Now, this is where things get complicated. This is a pretty hard thing to scale on very expensive queries, especially when you use this label selector as a form of like a source. So trying to compute that and codify basically a good data plane that is doing it correctly, it's pretty hard to maintain and scalable. And oftentimes, it's eventual consistent, right? Because and eventual consistency, before I even get to talk about it, right? Eventual consistency is often assumed in Kubernetes environments. So it makes you feel, OK, this is fine. But as I said, doing all these queries, tracking all the corresponding IPs, and appending the rules, have been proved to be very hard to scale. But the real risk is associated where where this eventual consistency can lead to permissiveness, and we had cases in the past where it happened. So we as the community, we feel the obligation to say, hey, maybe we could improve on that and make sure we're providing better UX for users. Now, lastly, and kind of entering more to the model we're proposing and the model we're hoping to get, I want to quote John Howard, which is not here today. But John is basically comparing this problem to a security checkpoint where an officer checks for employees. And John is saying that the strengths of this checkpoint vary substantially based on how we identify employees. Whether it's a badge, whether it's a company T-shirt, whether it's a fingerprint scan, all will produce widely different outcomes. And the same applies to network policies. And I'm going to let Keith walk us through the model we're proposing, what we're hoping to get with identity-based policy model.
Yeah, so we've kind of buried the lead a little bit on this, so kind of apologies for that. This first part of the presentation has been sort of just catching everybody up to date on what exists in the ecosystem today. The reason we're doing this presentation is because we believe that Kubernetes needs a network policy or a network-based policy that can work with identities. And so, as Lior mentioned, there's a lot of good properties that identities provide. And so the rest of our time, we're going to try to get finished a little bit early so there's time for questions. The rest of our time, we want to spend talking about the considerations for building such a policy API and what are the trade-offs and things we need to keep in mind. So these 4 questions are not exhaustive, but they're 4 really key questions that we need to be able to answer in order to build a workable identity-based policy API. And ideally, we need to answer this question for every single workload in our system. And the answer for these questions should be the same for every workload in our system in order for it to actually be feasible. And so the first question is, where do we derive the identity? Given a workload, what characteristic does it have? And what characteristic can we use to create that identity? If you think about a Kubernetes pod, they've got an ungodly number of fields. What field do we use in order to create the identity? Because we're doing this validation over a network, we need to figure out how do we transmit the identity from one workload, one entity, to another entity. The next question is sort of feeds into this that second question. How do we encode the identity? So when we send it across the network in some way, how do you represent that identity? How can it be read? How do we get the bits onto the wire for that identity? And then finally, at what layer of network encapsulation is the identity available? If you think about the different layers in the network OSI model, we need to figure out where we need to transmit this identity and make that information available so that things that sit on the network can use it. So can my TCP client or server make auth decisions based on my identity? What if my server is HTTP? If it's gRPC? We need to make sure that for the wide number of different kinds of workloads that run on Kubernetes, the identity is going to be accessible and available. Looking at the ecosystem helps give us some sense of prior art. Where has this been done before? And I've just got 2 examples. There are several more. But I've got 2 examples here that I think sort of show the need for some standardization. Cilium is an extremely popular and robust CNI that provides some identity-based policy via the Cilium network policy, CRD. The way that this works, and yes, I checked with Nick Young before this session, so he tells me that I'm not too far off base at least. But the way that this generally works at a high level is that identity selection is done via labels. So a set of pod labels translates into a Cilium identity. And we've got this chart, this picture on here that shows sort of how that works at a high level. With Cilium network policy, you can enforce traffic in both directions, egress and ingress. And you can do that for each pod that is sort of running with the Cilium CNI. And this implementation is a bit more performant network policy because the identity spans across multiple pods. So if you've got 2 pods with the same set of labels, that has the same identity. The other example here is Istio, and Istio takes a completely different approach. You've got pod identities that are one-to-one with a Kubernetes service account. And so the details of the implementation are there, and I won't go through all that for the sake of time. But the key thing to take away here is that with Istio, instead of a label selector, or a label set rather, the identity comes from a service account. Policy is also only enforced on ingress instead of egress. Istio doesn't actually have any real per pod egress policy. And with Istio, you can write allow and deny rules in your authorization policy resource. And I've got an example of such a resource down in the bottom right. And the big takeaway here, again, there are a lot more examples. We can go in a lot more detail. But the big thing I want you to take away here is that on just those 4 questions that we talked about identity derivation, transmission, encoding, layer, Istio and Cilium have 2 vastly different implementations. And just getting identity from Cilium to Istio or vice versa is extremely difficult. There's no standardization in the ecosystem, but even just between these 2. And so as we talk about how do we move toward a standard, we need to think about what entities are going to be covered in our scope, right? So in the course of east-west authorization, do we need anything beyond pods in Kubernetes, right? That's our atomic workload unit in Kubernetes. Do we need anything beyond that? Right now, you see a lot of cloud providers that have some workload identity thing, whether that's like IAM in AWS or GCP service accounts, or Azure identities, et cetera. They all kind of work with Kubernetes pods in a somewhat standard, similar way. You have pod service accounts, you've got the namespace boundary, and then pod and workload labels. We've seen examples of all of those in the slide deck in our presentation today. But there are other identity types out there. You've got JWTs. Spiffy does certificate SVIDs. They also do JWT identities as well. So that's an option that's very common. OIDC for login flows. You often see that with like human auth. RBAC roles and groups in Kubernetes. There are lots of different things we could target. And that's just within sort of the CNCF Kubernetes ecosystem. What if we start talking about VMs, mainframes? Anybody? Look, what is our scope of entities that we need to be able to write off policy across? That's kind of the first question. From there, we need to figure out how we're going to target those workloads with our policies. Should identity be a source? Should it be a target? Should it be both? There are implementations out there that already leverage identities as a source. So this thing that I'm attaching my policy to should only accept traffic from X, Y, or Z identity. But even though some of those exist, pod labels remain by far the most common and prolific target. Usually you use a label selector in order to say that this policy applies to this pod based on label selector. Potentially, we could leverage identities as a target as well. So instead of saying this set of label selectors describe what this policy belongs to, maybe you say this policy belongs to this service account or applies to this service account or this identity. Who knows? In this table, we've got a set of characteristics and sort of criteria that compare identities and service accounts for targeting. The big thing to keep in mind here that differentiates them is that the attacker's compromise pod, if you've got a identity as a target, the attacker's compromise pod could receive traffic it's not supposed to receive, but it wouldn't be able to send traffic to unauthorized destinations. So again, don't have, Lior's going to get a little bit into some of our some potential answers for some of these, or what an API could look like. It's just meant to get your brain thinking about some of the problems in this space.
Right. So another thing I want to mention here is, often when we talk about policies, right, we have different layers, right? Even in East-West, right, doesn't matter. And these different layers have different attributes. And we usually reason about it, we think we have 2 layers, right? We have the L3-4 and we have the L7. But in fact, we really have like 3 layers, where, the L3, L4 layer where we can get IP addresses, ports, protocols. We have the L4 TLS layer where we can get everything from the TLS handshake, whether it's, MTLS certificates, things encoded in the X509 certificate. And we have the L7 layer, right, where the L7 attributes are coming, and, headers, jots, whatever. But current implementations usually combine these layers and these attributes in the same CRD. And oftentimes, they have different semantics for when the policy, for example, has L7 attributes, but the traffic is L4 or L3. Some of them slightly ignore L7 attributes. Some of them default to denial if they don't have access to these attributes. And this is pretty confusing. It's been reported in a lot of repositories as well for some implementations. And even more, there's some that have different enforcement points for these different layers. So as a user, how do I know why my packet has failed, why my packet has denied? Where do I go to check? And this leads to a less clear security posture. And to the question, which again, I hope we still have time to discuss this today, do we need separate OSI resources for different layers? And just to kick off the discussion, and I'm not going to spend any time, going over these, but this is just a pseudo API, nobody has elaborated on this. It's just to kick off the discussion to try and get some feedback. But this is how it could look like, right? On the left, we can have a network OSI policy, whatever we call that basically targets this lower layer. And on the right, we can have the app OSI policy with all those, all these options. And I plan to elaborate a little bit more, but, again, hopefully we can come back to this in the end. But this basically leads to the question, can these compose? Or even more broadly, when a policy is written, how the operator knows which layer is actually enforcing it. And similarly, as Keith mentioned earlier, if the identity is distributed L7, how can an L4 CNI or any L4 enforcement layer can access it? Now, if the first layer does not have access to the identity, should it reject it? Should it delegate it to the second layer? Similarly, how do we avoid double enforcement? Now, more of a future looking, right? We have some CNIs that kind of do encryption. How can the mesh see what it needs to apply further authorization or even routing policy if CNI encrypts? And if the mesh is going to encrypt, how can CNI ensure that the traffic in the cluster is encrypted? Do we even need to be distributed? So all of these things, and this is just a brief, we call the composition problem. And we ask yourself, can these identities and policies even compose? Now, some of the open questions. How do we split enforcement between CNI plugins at L3-4 and mesh implementations at L4 TLS and L7? Do we need a network class? It's been discussed for many different reasons, some of them being DRA recently, but this is also relevant. Maybe we have a network class and every component is responsible for enforcing that, and this has come with many different arguments for both sides. Now, how far we can get with service account as an identity? How can we represent identities outside the cluster? Is SPIFFE a generic enough mechanism we can all converge on? What about grouping? Do we really want to support grouping? How much interest there is in identity as a target? As I said, most of the implementations doing pod labels today, but is identity as a target something we could actually feel will make life of users easier? What about different authorization resources for different levels? Is it going to provide any meaningful improvement for users? How can we make it easy for implementations to adopt? How can we leverage CAP 4317 for those who, this is the pod identities cap, if you ever read that, which basically says that kubelet is going to issue identities. And is kubelet enough as an issuer? And how do we even plan to use this search that kubelet issues us from within and from outside the cluster? Now, last question, where does APIs should live? Is it gateway API? Is it network policy API? And how can these two groups kind of collaborate together? Now, I'm not sure how much time we still have left.
4 minutes.
4 minutes, but we did want to get a lot of feedback, and all these questions are, up for debate. And what we're hoping for is to get the work stream started out of it and kind of work towards standardizing it in Kube.
So if you've got any questions about anything you just talked about, Mike is there.
So I don't know if you've thought about this at all, but after we talked about this at the last KubeCon, the big problem with the TLS-based versus the IP-based is not just that they're looking at different levels, it's that the TLS-based authentication can't even start trying to figure out if the connection is accepted or not until after the IP-based connection has already completed. And so that makes it very hard to, have you thought any more about that at all, or is it still totally unsolved?
Yeah, I think, my perspective is I think eventually, and reading, we have an issue, by the way, that we should have linked that has some discussions from all of us that included on the network API group. I think eventually it will have to compose, right? Because things like admin network policies, they're still relevant, right? There's a lot of users that want it, they need it for different cases. Also users that are used to do like more firewall-based rules. And these would need to compose, but the question is, okay, how they are composed, whether CNI would ever have any access to any sort of identity which is not an IP, for example. Eventually they could be like, CNIs and mesh converge to one thing. Yeah, I mean, it's just, I don't have a good answer yet.
I think generally what I'd say is there's no good answer. There's no one great answer for the composition problem.
Right.
In order to make this work, what we're going to need to find is a set of acceptable trade-offs for groups involved. And so I think what Lior is saying around composition is going to be key, because you essentially, when it comes to TLS-based authorization, you've got to have some cohesion between whatever's doing your L3 enforcement, whatever's doing the TLS enforcement, and what there's prior art for the different layers communicating, but it's still largely an unsolved problem. We'd have to solve in order to get this to work, I think.
I think it has to come from Kube as well, right? Because, for example, today, if you want to do default deny, right? And then you want to do some identity mesh, so then you cannot compose any Cilium or Istio.
I mean, definitely lots of people want the TLS-based authentication.
Right. And then, like, ideally, I would recommend, hey, just do a default deny with baseline network policy, or like just do a default deny posture on the IP level, and then, the other API, the L4 TLS API or the L7 can compose and allow the traffic based on that. But right now, because it's all different implementation, nothing is converged. So
well, and because if you have default deny at L3,
exactly,
you would have to kill the connection before you could even look at the TLS certificates. So yeah. Okay, we'll keep thinking.
Room for thought. Yeah.
I think there's also really good thinking going on here, which is great to see. I guess I wanted to just make a couple of observations from the kind of Cilium point of view. One was really very much echoing what the previous person said about, the layers are there for a reason. Mm-hmm. I think the network layer can see what is passed down to it from the application, but it's much harder to go the other way and have an application layer thing understand what's happening in the network layer. I guess the second thing to point out is not all traffic is TCP, and things like TLS. If you're going to do MTLS, you can only really do that over TCP. We did some funky things with Cilium to allow to do the handshake for other kinds of traffic, but it's not the MTLS that we know and love. And I guess the third thing that I think was a really neat thing that we did in Cilium was the idea of putting things like network level encryption into the network policy. So if you define a Cilium network policy, you can say for traffic, between endpoints identified like this and endpoints identified like that, we require encryption. Right. Which I'm just throwing it out there as something that it wasn't my idea, and when I saw it, I thought that's really neat.
Sorry, you're saying it's a way to require encryption?
Yes.
Yep.
Yes. So you in the network policy, there's like a field that basically says
Yeah,
encryption required. Yeah.
Yeah, I think Cilium definitely has, because you're at the network layer, you've got the ability, like to your first point, to see and communicate through the different layers in your stack. I think if Kube is going to solve it, is going to try to standardize it, then you've got to find a way to basically do the same sort of context passing in a standard way, and that's the difficulty. And I think there's a lot we could learn from Cilium, from how it's expressed in the API as well as what's happening at the network layer. I'm curious to see, like with UDP, for example, to your point about TCP, I'm curious to see what things like Quick do, because it's not UDP in the way we know and love, but there have been attempts to try to put some TLS at the UDP layer and try to make that work. But it's definitely something that we need to consider to make it feasible.
Yeah, cool. Thank you.
Thanks. I think we've got time for one more because yeah. OK, real quick. Go ahead, Flynn.
I kind of feel like we're talking about two separate concerns that have been conflated here. One of them is, what sort of identity standard could we use at layer 7 for east-west traffic, which seems like a thing that could benefit from some standardization. But the other one is, to me, feels like, how do we combine the L4 network auth, L3-4 network auth with L7 network auth? And I would love to hear more about the user story driving that concern, because as Liz pointed out, the layers kind of do exist for a reason. And it's much less clear to me that you couldn't have the mesh just writing L4 network policies for you, for example, and then sticking with L7, that sort of thing. So I'm curious what the user story is that's driving the desire to combine those two things and driving these two different concerns together.
Right. It is the UX experience that you're sort of describing, right? Is that if the mesh, if you want to use your mesh to write everything, then great. But if you've got a situation where you've got your CNI enforcing layer 3 and a mesh that doesn't enforce network policy, then you're sort of stuck, right?
But you're also assuming that all mesh is operating in L7, and there is, the reality is there is some meshes out there that kind of going to a place.
I'm assuming that if you're doing L7 auth, you are operating at L7.
No, right, but
I'm not
as far as I
necessarily
understood,
assuming
as far as I
that's the
understood,
only place you're operating.
As far as I understood, your user story was like, why do I need an identity on a mesh level lower than layer 7, right?
No, my question was, what is the user story that is driving you to want to do L3, L4, L7 in this unified way, as opposed to continuing to treat them different, with different policy objects, for example?
It's really the ability to similar to the reason for, I think, Gateway API in general, is if you've got disparate things, maybe you use Calico on day one, you want to put the mesh on top of it, and you don't want to rewrite all of your policies in the mesh-specific flavor. Like, that's really the main use case there, where you need to be able to do that context passing in a predictable and standard way. If you can use just your CNI or just your mesh for all of your policy, sure. But I think that when you've got a mixed case is when it gets more tricky. And we're seeing a bit of that, I think, as people try to optimize their solutions and they want to pick, maybe their CNI gives them more throughput and performance, but they want their mesh for the L7 bits, trying to find an answer for that question.
Yeah, I think we're going to have to take that one offline a bit.
Yeah, let's chat.
Let's do it.
Let's chat.
Thank you.
Thanks. We're out of time. Thanks, everybody.
Thanks.